This video is for section 5-4, multiplying and dividing. A product of fractions equals the fraction whose numerator is the product of the numerators and whose denominator is the product of the denominators of the given fractions. Here are examples of what that means. Let's say we want to multiply these two fractions together. We want to find the product of fractions. The numerator is the product of the numerators. 3 times 7. The denominator is the product of the denominators. 8 times 5. This answer is 21 over 40. We multiply fractions involving algebra expressions in exactly the same way that we multiply regular fractions. The second example, if it helps you, you can put a 1 underneath to help line up what's in the numerator and what is the denominator. Multiply the numerators. And multiply the denominators. And simplify. 2 times 3 is 6. K to the third power all over m. Next example, we want to multiply these fractions together. Multiply the numerators. 6 times the x times x plus y. And multiply the denominators. The x plus y times the 3. Then simplify. The 6 divided by the 3 makes 2. There's a factor of x in the top, no factors of x in the denominator that would do any canceling, so there's an x left over. Now what happens to the x plus y's? The x plus y in the top and the x plus y in the bottom cancel away. The final answer is 2x. You can often simplify products of rational expressions by factoring numerators and denominators. Here's an example. We want to multiply these fractions. To help us do that, let's factor all those polynomials. Starting with this one here, this has a GCF of 5, leaving v plus 1. In the denominator, this is a difference of cubes. It factors with a double parenthesis pattern, a smaller parenthesis and then a larger parenthesis. This is v minus 2. Then v squared plus 2v plus 4. We learned how to factor difference of cubes in our earlier chapter. Now let's go over and factor this right here. This is a perfect square trinomial. It factors as v minus 2 squared. Finally, the v squared minus 1. That's a difference of squares, and it factors as v plus 1 times v minus 1. So what's been done so far is the fractions have been combined together by creating the product of the numerators and the product of the denominators, and at the same time, we factored the polynomials. Now let's look for common factors to see if anything cancels away. The factor of v plus 1 in the top cancels the v plus 1 in the denominator. The v minus 2 in the denominator cancels away one of the v minus 2's in the numerator, leaving one of them left over. There's no other canceling. So the final answer has a 5 in it and a v minus 2. And in the denominator, it has the v squared plus 2v plus 4 and v minus 1. So we just worked some multiplication problems involving fractions or rational expressions. Let's try some division problems. One way to simplify division of fractions is to use the definition of division that we studied on page 28 of the book. The definition of division states that dividing by a fraction is equivalent to multiplying by its reciprocal. So we can take the fraction negative 16 over 9 and multiply by 15 over 22. That is equivalent to this original division problem. Now work it out just like a multiplication problem. Multiply the numerators together and the denominators together. Then simplify. Let's do a little bit of reducing. The factor 16 and the factor 22 are both divisible by 2. 16 divides by 2, leaving 8, and 22 divides by 2, leaving 11. The factor 15 and the factor 9 are both divisible by 3. 15 divides by 3, leaving 5, and 9 divides by 3, leaving 3. Collecting up what's left over, we have negative 40 over 33. Let's try the next example. Here we have division. We can apply the same rule, change to multiplication, and take the reciprocal of that second fraction. That allows us to rewrite the problem like this. Now factor all polynomials. This trinomial factors using the double parenthesis pattern. 5 times 3 is 15. And putting a negative k here and a positive k here will make the negative k squared. And the outer and inner products combine to positive 2k. The trinomial on the bottom is a perfect square trinomial, and it factors as 1 plus k squared. K squared minus 1 is a difference of squares, and it factors as k plus 1 times k minus 1. This trinomial here has a GCF of 2, leaving k squared minus 6k plus 5. The k squared minus 6k plus 5 is a factorable trinomial. I don't want to rewrite the entire problem, so right underneath that, let's just replace it with its factored form. 2 times k minus 5 times k minus 1. Now let's look for common factors that cancel away. 1 plus k is the same thing as a k plus 1. So the k plus 1 factor in the top will cancel away one of these, leaving 1 left over. There's a k minus 1 in the top, which cancels a k minus 1 in the denominator. There's a 5 minus k factor in the top and a k minus 5 factor in the denominator. Those are opposites of each other, so they will cancel away, leaving negative 1. The final answer has a negative sign in the top, the factor 3 plus k, and in the bottom there is a 2 and a 1 plus k. Let's summarize the lesson. We reviewed multiplying and dividing fractions, but we extended our skills to fractions that have variables in them. The technique for division is to change into multiplication by multiplying by the reciprocal of the second fraction. If there are polynomials, factor them, then cancel like factors.